In our second video on simultaneous equations, we're now going to look at the substitution method. And from using the substitution method, we'll be able to identify a point of intersection. So we can actually use this method without having a graph for us to see where the point of intersection is between the two graphs. And what we really want to do is we're going to substitute one equation into the other. For our first one, we want to solve the following simultaneous equations using the substitution method. Okay, y equals negative x plus 5 and y equals 2x minus 4. So what we're going to do is substitute one into the other. And therefore what I'm saying is, if 2x minus 4, that's what we're saying y equals. So therefore it equals negative x plus 5. Okay, and now we have our equation. Just like we've done before, we want to get a value for x. Okay, so I'm going to plus x to both sides because I want x to be on the left hand side. That'll give me 3x minus 4 equals 5. I'm going to then plus 4 to both sides. That'll give me 3x equals 9. And my final step, I need to divide by 3. And that'll give me x equals 9. Okay, and now I can substitute that into either of the equations. First, I should have identified, I would call that equation 1 and equation 2. So I just substituted equation 1 into equation 2. So x value was 9, and now I'm going to do it over here. I'm going to substitute x equals 9 to find the y value, or y coordinate, into y equals negative x plus 5. Okay, so y equals negative 9 plus 5. So therefore y equals negative 9 plus 5 is minus 4. So our point of intersection, I'm going to call it POY, is for both of these, we give our x value first, 9, negative 4. Look at our second example. Okay, I'm going to call this first one equation 1 and equation 2. This is a little bit different to the last one because both equations equaled y. But what I'm going to do is sub equation 1 into equation 2. Okay, so I'll rewrite it out. Now, I'm going to substitute equation 1 into this equation. So 3x plus 5. And from equation 1, we know that y equals x plus 1 equals 7. So now I'm going to expand out. 5 times x is 5x. 5 times 1 is 5 equals 7. Collecting like terms, 3x and 5x is 8x plus 5 equals 7. Now I'm going to subtract 5 from both sides. That'll give me 8x equals 2. Final step, divide by 8. So therefore x equals a quarter or 0.25. Now I'm going to substitute. So sub x equals 0.25 into equation 1. I'm going to rewrite equation 1, so y equals x plus 1. We get y equals 0.25 plus 1, so y equals 1.25. So our point of intersection is 0.25, 1.25. Okay, remembering our x coordinate is first, our y coordinate is second. Now, moving on to our final example. Okay, first thing we needed to do was identify equation 1, equation 2. And I'm just going to sub equation 1 into equation 2. So therefore, I'm going to say 5x minus 1 equals 11 minus 3x over 2. So straight away I want to get rid of that 2, okay, and get rid of the fraction. So I'm going to multiply both sides by 2. They'll cancel that out. And remember, when I'm multiplying that by 2, it becomes, I multiply everything by 2. Now I need to expand out. So 2 times 5x is 10x. 2 times negative 1 is negative 2. Alright, now let's collect all the x's to the left hand side. I need to add 3x to both sides. That'll make it 13x minus 2 equals 11. I need to get that negative 2 to the other side, so I'm going to plus 2 to both sides. That'll give me 13x equals 13. Final step is divide by 13. So therefore I get x equals 1. Now I'm going to sub x equals 1 into equation 1. Okay, equation 1 is y equals 5x minus 1. Okay, so there we have 5, y equals 5, 1 minus 1. So then y equals 5 minus 1, y equals 4. So our point of intersection is 1, 4 for these equations. So the first thing we did when we were working with the substitution method is identify equation 1 and equation 2. We then needed to decide what we were going to substitute in. So are we substituting equation 1 into 2 and so on, and then work through and solve and find x to begin with, or y, and then substitute that value into one of the equations to find the other value to get the point of intersection.